Antimicrobial resistance is one of the top global public health problems, and bacteriophages might be our last beacon of hope in the fight against superbugs. The first step in personalized phage therapy is the isolation of drug-resistant bacteria from the patient. Once the infection is determined to be resistant to all available antibiotics, the medical team can choose to administer phage. The bacterial isolate will then be sent to a laboratory that has phage biobanks. These are usually specialized research facilities with trained personnel. This is where the bacteria isolated from the infection is screened against the phages in the biobank. Screening is commonly done through culture techniques, which are laborious, lengthy, and not suitable for high-throughput implementation. This is a race against time when a patient's life is hanging in the balance. Biobanks are stored in these labs as liquid vials or freeze-dried powders in a fridge or freezer. This requires a large footprint just for storage, with multiple trained personnel for handling and screening. Besides, this format makes duplication and sharing of these biobanks almost impossible. What makes this process even more challenging is that a global biobank for therapeutic phage is non-existent. Therefore, to find a phage against a bacterial infection, the medical team may have to navigate multiple biobanks in different locations around the world, sometimes shipping the bacteria to these locations for screening. This is not only unsafe, but is also highly inefficient. This is a complex problem that undermines accessibility to phage therapy for critically ill patients who need it the most. We have reimagined phage biobanks not in the form of vials upon vials stored in large footprint freezers, but in the form of dried pills, stabilized in microtiter plates with a footprint no larger than a paperback book. These pills contain phage along with a biochemistry that allows for rapid screening of the biobank when and where it is needed. By simply adding the bacteria of choice to these pills, the embedded biochemistry in the pill will result in the target phage or phages to glow in as little as 30 minutes and up to a couple of hours. Our technology makes it easy to replicate phage biobanks and to store them without specialized conditions and in redundancy, ready to be shipped around the world at a moment's notice. When needed, biobanks from multiple locations can be rapidly shipped to the point of need in a safe manner, where they can be either duplicated or rapidly screened against the bacterial infection. This will lead to timely identification of therapeutic phages that can save lives.